What's happening today with membranes in hydrocarbon extraction? I know you've been doing some research with our partner over there at Molecular Forces. So what's the latest and greatest update on membrane research with butane and propane?
Yeah, Zev and I are wrapping up the R&D phase and working into a commercial prototype unit currently. With the membranes, we have in butane we have successfully separated cannabinoids and terpenes as well as cannabinoids and solvent. It looks like we will have a nice little skid for people to plug and play into their existing units from any manufacturer to achieve the benefits of membranes in their process that membranes offered ethanol extractors years prior, which is tremendous energy slash OPEX savings. When you do not have to add as much heating or cooling energy to remove separated solvent, that's OPEX savings right out the gate. And when you're able to do these things while also adding even less heat, butane as it is, there's not much heat imparted to the mixture for the bulk of that solvent to be recovered. Anyways, but there is a benefit even further when not having to add any heat at all. And that solvent is staying totally in its liquid state and there's no phase change. So the chance for entrainment of these very, easy to lose odorants that give an extract its particular character. When that chance that they could be entrained in the solvents being evaporated is gone, you have a higher chance of retaining as much of that original plant flavor as possible. And that's what's exciting, is to see this technology applied to both high-end extracts and, low-end extracts that may go on to other end product processes downstream.
What are the main applications that we're looking at membranes for in hydrocarbon extraction today?
Solvent recovery, first off. Second off is dewaxing and decoloring, as well as separation of terpenes from cannabinoids, which we recently had a very successful trial in that particular regard.
That's incredible. So not only for extractors focused on producing dabbable products, but also for extractors focused on producing ingredients and terpene flavoring for vapes and for other products, and pure cannabinoid cuts for things like edibles. So that's greatly expanding the capabilities of these hydrocarbon extractors with a plug and play type of system. This is something I think people have been asking for a long time.
Yep, and it's taken a lot of work to develop. There are inherent challenges when working with, solvents like butane and propane. Not, their flammability, handling that and ensuring safety is easy, right? But these solvents are different to work with than, say, a normally liquid solvent at standard temperature and pressure. So that on top of membrane selection and process optimization in terms of the operating parameters to get what we need out of a particular material is, it was a fun challenge.
We're very excited to get this product to market, and we'll be looking for early adopters out there that are interested in getting these systems in their labs, this year in the next 2 quarters. So we're very excited to speak with, highly proficient operators that have specific use cases for these membranes, that are familiar with integrating brand new technology into their systems. We're very excited to start working out there in the field with operators of that kind. One last thing to say about these membranes is, usually processors are used to thinking in, how many pounds can I evaporate a minute? Right now, on our biggest extraction system, the HVH50, we're at 10 pounds a minute or greater solvent recovery through distillation a minute. But going towards the membranes, it is completely feasible to be, pumping through gallons a minute of solvent recovery. So, It's only a matter of how much surface area of membranes you have as far as how much solvent you can recover in a given period of time. So the scalability with this type of system in a relatively small footprint is very great. So we're really looking forward to working with folks not only on implementing this for producing novel, high quality products, but also really massively increasing the potential throughput of extraction systems that are occupying relatively similar footprints to what people are already working with. So that's very exciting potential for the use of these membranes. So what is the difference between, say, an ethanol extract versus a light hydrocarbon extract when it comes to, marketability in the market, and why are they so different?
Yeah, ethanol extraction pretty much limits you to a smaller range of end product consistencies, simply because of the nature of the solvent itself. Compared to light hydrocarbons, ethanol is a polar molecule. And in that regard, ethanol easily pulls much more colors from the plant material, and it is way more difficult to remove those colorants. So already you're faced with that challenge. And that's an important challenge because that impacts how not only your distillate will look, but also, any other extract that you produce with ethanol. Now you can lighten it up. Yes, you can, but that takes, a lot more consumables, and you're not going to achieve the same degree of decoloring that you can achieve with a hydrocarbon extract. And also ethanol extracts a lot more, plant lipids. It penetrates that cell wall a lot easier than, cold butane does. And you have to remove that from your oil. If you're going to distillate or, even a crude to sell as a edible formulated product. Not to mention there's the terpene retention with ethanol extracts is far less.
So ethanol is an option for folks that are looking to produce, bulk crude or going to distillate. But even in doing so, it does require more work on the extract to achieve a starting point where you can go to that next step, be it going into edibles or going into your distillation process, because you're pulling more fats, you're pulling more colorants, and in a lot of cases, you might be pulling carbohydrates that can negatively impact your quality. Dabbing an ethanol extract directly, while it has been done, and these are products that are sometimes marketed in the industry, most consumers find them to be harsh on the dab, and don't perform very well in the nail, both for flavor and for the customer experience overall. So generally, ethanol is not looked to as a method for producing dabbable products unless there's an absolute necessity to do that because of regulation. Now, that said, we should also touch on the solventless side. Solventless extracts are very popular right now, especially for the very, very high end, but there's some constraints on production of solventless extracts as well as their quality that we should definitely mention. John, what is the use case for a processor when they're comparing, okay, we want to focus on solventless extraction versus we're going to go into the business of producing hydrocarbon extracts?
Up front, implementing a solventless extraction facility is a lot cheaper on the CapEx side. And it is attractive to newcomers to the industry because, hey, there's no, C1D1 room required. It's a safer process to operate. And, those are true. But at the end of the day, to achieve a viable business model with solventless, you're really, really restricted to the material that you can run and achieve predictable extraction yields. Not to mention the labor required in all that. Now there are more automated, mature technologies on the bulk extraction of those trichomes with water, but the rosin process itself is still pretty much done by hand and hydraulic presses, and you're limiting yourself, in my opinion, when only going with solventless, due to some varieties just do not wash well. And you talk to any solventless operator and they'll tell you that. The cool thing about it though is those guys are really focusing on breeding plants for high yields, or easy washers as they call them, or good washers. But still, you're not going to be as versatile of a business if you only do solvent.
Yeah, a couple of other key factors in deciding whether that business model is right for you is when you go for solventless and you're using water in your process. Water is by its very nature going to introduce the risk of mold. It's going to introduce the risk of other contaminants, even things like yeast and bacteria. So you have to have a very meticulous, clean process with a lot of focus on cleaning your equipment as well as your storage facilities to make sure that you're not, going to create an environment that is friendly to the growth of those microbial contaminants. In addition to that, keep in mind that the risk of flame in a butane or hydrocarbon extract facility is a present risk, but we have a lot of protection equipment, safety equipment that's built into the facilities to mitigate that risk. Whereas when you're producing a rosin, you're using a high-powered hydraulic press, the risk is very present to workers of crushing, cutting, pinching injuries. So in some ways, you have a less extreme risk when you're pressing rosin, but you have a more directly present and not preventable risk in that facility. And this is just the same as being in a machine shop when operating hydraulic presses for those types of facilities. There are a lot of regulations to keep in mind when using that heavy machinery, and the same thing applies in a metal shop or in a rosin press environment. Lastly, a key thing to take into consideration is it might be cheaper to set up your facility initially when producing rosin, but there's a real question about what is the cost per unit capacity of production that's achievable with solventless type of extracts. And the truth of the matter is they take up a lot of space. They are going to be limited in per operator how much extract you can produce just because of the manual small batch necessary technique that's used to produce the rosin. Your maximum output per hour or per week in that facility is going to be relatively low as compared to the same floor space, the same number of workers that it would be with an appropriately scaled hydrocarbon extraction system. So that limitation really is forcing the prices on those solventless extract to stay high and the margins to shrink because the marginal cost of each piece or each unit of solventless extract is simply going to be higher. There's really no way to get around it.